Alright, so everything that we've been doing up until now is basically like, let's take some data where we already know about all the data and then do something with it. Like if we are rolling a die, we already know what the probabilities of the die are going to be. We already know what basically we know what our probability distribution would look like. We just, if we take a sample, what's the chance that our sample is going to look like this? So with probability stuff, especially like rolling a die, that kind of thing makes sense. Now, if we're thinking about statistics most of the time, like the way you think about it, so like I want to know information about the school, I want to know information about people, I want to know information about the average height or something like that. It's not usually going to be the fact that we know the information about everybody and we're going to use it to take a guess for what our sample would be. So like I'm not going to know exactly what, it's like going and voting stuff. Before people vote, I don't know ahead of time what people are going to vote for, but I take samples to guess what it's going to be. So that's the whole idea of where we start today, is taking samples to guess what the population distribution would actually look like. Vocab today is extremely important. Some of it we've talked about. Notation of symbols starts to get very important this chapter. And up till now, I've just said, this is what the symbol is. Kind of remember that. But now it's like, if you don't use the right one, I'll come off. All right, so we have two different things. We have a parameter and a statistic. And we have a population. And y'all need to write this. I'm talking about your notes. I just don't have it written up. You have two things. You have a population and a sample. So I'm going to have a number that describes the population. I'm going to have a number that describes the sample. So let's say all seniors' GPA at JLMAN has an average of 3.0. Just giving easy numbers here. So the 3.0 would be talking about the population. So that would be talking about this word, which is your first blank, which is a parameter. So a parameter is a number that describes a population. So let's say the whole school senior class has an average GPA of 3.0, so that's what would be here. Let's say we did it just for our class, for the seniors in this class, say it's a 3.5, that would be a statistic. So this is your, I think, second one. So a statistic describes a sample. A parameter describes a population. And so that's vocab that you need to know the difference in there. Skipping down to where yours says mean, standard deviation, proportion, and then it says statistic and parameter. So your paper already says that. So what is our symbol for mean of the entire population? What's our symbol for mean of a sample? Y'all know this. X what? X bar. X bar is of a sample. I'm probably going to have to use my other thing. And then what is it for mean of a population? So I started to say this earlier. U. These are things that like you have to know. You use them incorrectly. Now, I do think some people get confused with the symbol mu. To me, it looks like a fancy somewhere between an M and a somewhere between a U, and it's spelled MU. So that's kind of how I remember it. But sometimes when they're typed, they look like this, and they look a little bit funnier, kind of. Oh, yours isn't on there. So sometimes they look weird like that, just because of the font. But I always write mine like that. So standard deviation. What is standard deviation of a sample? I should know the symbol for standard deviation of a sample. What is it for a population? What is a standard deviation symbol we know? Sigma. What's the other standard deviation sample we know?
S of X.
S. So which one is parameter? Or which one's the population? And then S. And so S and S of X, some people just do like of X means of that distribution. So lowercase s is standard deviation of a sample. Sigma is standard deviation of a population. I don't think we've talked about the proportional one at all yet. So like from last chapter, if I talk about a proportion of something, we just call it what? Don't overthink this. P. Proportion of a sample is P. It's actually called P hat, and it looks like P with a hat on it. We have not talked about that one yet, right? So going back to what I said here with this one, and you don't need to write this just to kind of tie in things. The example I said was the whole school had a mean of 3.0 GPA, and if our class seniors, they're supposed to be equals, not Z's, had a 3.5 GPA, what would be my symbol for the 3.0? Mu. And so that would be a parameter. What would be my symbol for my 3.5? And that would be a statistic. So kind of seeing what we're actually doing with these and how we're using them, I'm going to have to use other board. Do y'all have a blank in between the two things I just said? You said y'all do? Okay. So that section, I can't remember which ones I made blanks, which ones I didn't. The value of a statistic that varies in repeated sampling. So if I were taking a random sample, so here's the thought process here. Let's say I do not have access to school records to know the actual GPA of all seniors, but that's what I want to get. So I am going to somehow come up with a list of seniors and randomly select them and ask them what their GPA is, pretending that they can't lie or something, because that'll be a whole different issue. So if I randomly select a group of 20, I might get a GPA of 2.9 average. And then I go and get another sample of 20 randomly, and I get a sample of 3.4. And then I get another group of 20, and I get a GPA of 2.7. So it's not always going to be the exact same, because you might get a bunch of really high in there, you might get some low in there, you might get one low that really pulls it down. So this blank in between says the value of a statistic varies in repeated random sampling. This is just called sampling variability. Cannot write on this one. Alright, so most of the time, we're gonna actually take a sample and get one of these to estimate what this is, and that's why it says word estimates in between all this. Alright, so I didn't talk about it before, but what is the population? What is the population versus the sample?
Seniors.
So in our specific example, it would be all seniors at man would be our population, and whichever 20 seniors I selected would be my sample. So within problems, we are going to have to define your population and your sample. So number one, actually it says identify the sample of the population, and then I don't have, like, do you have underneath, do you have one or A or anything, or does it go straight into the Gallup poll? Identify population parameter sample statistic of the following setting. Does it just say the Gallup poll? No. So the Gallup poll asked a random sample of 515 adults whether or not they believed in ghosts. Of the respondents, 160 said yes. All right, so what is our population? Actually, let's back up. What is our sample?
515 adults.
And it doesn't really matter if you include the number 515, but most people do to help them out, but it's specifically the 515 that were what?
Chosen for the poll.
They were chosen for the poll. So the 515 adults that were did it give us a word surveyed selected sample? So we've talked about this before. You back up to the group that could have been selected. So we talked about this with sampling techniques. So our population, based on the very, very, very generic wording of this problem, what would be our population? Adults, like, it should have probably been a little bit more specific, but I'm just gonna say all adults. Gallup poll, I think, is US, but it might be like just the 48 contiguous or whatever, but, so we're just gonna go with as specific as the problem is, but not adding anything else. So we also need to define statistic and parameter. So which one does it give us, a statistic or a parameter?
Statistic.
And of our three options, X bar, S, and P hat, are we talking about a mean, a standard deviation, or proportion? Proportion, so it is going to be a P hat. And now it doesn't just flat out give us P hat, it gives us two numbers. What are the two numbers that it gives us? 160 and 515. What is our 515? So what do I write as that? Symbol? Letter?
X1.
Sample size.
Yeah.
And this is stuff that we've talked about along the way, but I haven't made a big deal about it. I'm starting to make a big deal now. So lowercase n is sample size. Capital N is population size. The one thing that I don't love about the way these notes are set up is it doesn't list lowercase n and capital N as statistic and parameter, but that's because we don't ever estimate the sample size or the population size. So it's not a sampling distribution, but it's still lowercase n is a sample is a statistic, capital N is a parameter. So the 160, just thinking about like context here, kind of applying to last chapter, 160 is our what? In general, it'll be our number of successes. What did we call number of successes last chapter? So this is, so how do I find this as a proportion? And leaving it that way is fine. I'm going to go ahead and write it as 0.3107. And round to 0.3107. So what we're trying to do right now is understand what the population is, what the sample is, and if our numbers are talking about the sample or the population. Alright, so below it says each boldface number is either a parameter or statistic. In each case, what it is, in each, state what it is, and use the appropriate notation to describe the number. I'm going to do this one as the same directions, define the population, the sample, the parameter, and the statistic. That's going to be your first question on, or a question on your quiz. It's next Monday. So I want to do it the same way that I'm going to ask it on there. So let's read the problem first. On Tuesday, the bottles of Arizona iced tea filled in a plant were supposed to contain an average of 20 ounces of iced tea. Quality control inspectors sampled 50 bottles at random from the day's production. These bottles contained an average of 19.6 ounces of iced tea. Kind of throwing in context here, we talked about sampling variability. Have you ever noticed when you go and buy like drinks off the shelf, some of them are a little bit higher and some of them are a little bit lower? That's sampling variability. There's quality control stuff to check to make sure that the sampling variability doesn't vary more than it should, and fall outside of a certain confidence interval, but we'll get to that. But so what the company does is have something that checks. They don't sit there and measure every single bottle before it goes out, because that would be pointless. But they have something that can measure like systematically every 50th bottle that goes out. And if of those randomly selected ones, it looks like it's too low, the product or the machine actually has to be adjusted. So like there's going to be variability for different reasons, but they have to keep checking it to make sure something's not so wrong that the system has to be recalibrated. So that's like the process of what's occurring here. So it's usually easiest to start with your sample. So which ones did we actually select here? So it was the 50 what? And this one's a lot more wordy than the last problem we did.
50 random Arizona iced tea.
More specific. By quality control, is that what you said? But we're still missing something big
From the day's production.
from that day's production. And I know that, again, like the wording stuff gets frustrating sometimes. But you think about it like working from a company, if I come to them and say, hey, you're underfilling, you're only filling an average of 19 ounces, that's a huge issue to them. But if I say it is they're averaging 19 ounces today, well, that means maybe we just made an error yesterday that we can go fix versus we've got to make up for something we've always been doing. So like all that context is extremely, extremely important. So population backs out to who could have been selected to be that sample? Who or what? So then, what could have ended up being that 50 group? And there's actually one other thing that's kind of picky here, but it doesn't say it very well, so I'll mention it and not write it. Actually, it's at this plant. So, which ones could have been the ones selected? Well, it's probably gonna be something with all. What are we talking about? Arizona iced tea bottles. So, to be part of this specific sample, which ones could have been? Ones that were what? What?
From that day's production.
In that day's production of that plant. From, I guess I should have said from, I'm not worried about that. Of that day's production of that thing. And part of why we have to be so specific is going back to chapter 4 with, did we select a biased group? Did we randomly select from that group? Because if we randomly selected, then we can generalize our results to that population, which is why that randomization is so important. All right, so sample population, so it's giving me two numbers, a 20 and a 19.6. Because, I'm gonna go ahead and write statistic first. And just because this is notes, I'm showing that those two are the ones that connect. So which number is a statistic? The 20 or the 19.6? 19.6. Is it a mean, standard deviation, or proportion? A mean, because it says average. So what is my symbol for average for proportion? Or average for mean? Mean for a sample? X bar equals,
19.6 ounces.
and my units, I gotta have the ounces right. And now some problems are gonna give us multiple statistics or multiple parameters, so it doesn't mean there's one of each. So what do I write for parameter? What symbol is this? U. And our average of the population should have been, and still my units of ounces. Questions on that?
Is everything there gonna be like what you want to see on the place?
Yes, yeah. And that's a very wordy problem. But, so somewhere between the top one and the bottom one, yes, it's what. Alright, I want you to look at B and try to write down your population and your sample. On New York to Denver flight, 8% of the 125 passengers were selected for random security screening for boarding. According to the Transportation Security Administration, 10% of passengers at this airport are chosen for random screenings. I'll give you a little bit of a hint here. What kind of sample is this? A cluster, because that entire plane was chosen. or all the passengers of that plane was chosen, all the passengers of that plane were then selected. And you don't need to like write that down, but that might help you decide back to your population. I don't want to waste time. At this point, whether you've written it down or not, you should probably have your answer. What is my sample? This should not be hard. What is my sample?
8% of passengers.
No,
125.
125. Because the ones that were actually selected. So 125 passengers on that particular, the 125 passengers on that particular New York to Denver flight is your sample. So who is your population?
Passengers at airport.
All passengers at that airport. Now, I understand why you're confused at this point, if you're getting confused with like little things. Because at this point, well, 8% of the 125 is what I want to deal with, okay, but think backwards and say 8% is my statistical parameter. Who does that apply to? And think about that one. So like there's a little bit at the beginning that'll be a little bit to adjust to, but you'll be fine with this. So now, what is my parameter? So just like I wanted on the quiz, like I know y'all can write out sample and population. I want parameter symbol equals number, just like I'm doing now for this part of it. So parameter, what symbol? Are we dealing with proportions, mean, or standard deviation? Proportion. So for parameter, should I write P or P hat? And then in this problem, which one is the one that's describing the population we just talked about? So that's what I would want to see on your quiz underneath. The sample is the all 125 passengers from that particular New York to Denver flight is our sample, and all passengers at this airport would be our population. So that's the next thing. And then under that, statistic. What symbol? What? P hat equals 0.08. And I don't care if it's proportion or if it's a decimal or percent. Writing 8% is fine. I'm going to skip around a little bit. Like, yes, we're actually going to take many samples, but I want to split a video here.